Good afternoon. Welcome to APA's weekly webinar series. My name is Billy Zadig, Standards and Codes Administrator for APA. Just a couple of housekeeping items before we get started. The webinar recording will be posted to the APA webpage later this afternoon. You'll receive a follow-up email in the next couple of days with a link to the webpage where all webinar recordings are housed, as well as a link to our upcoming webinars. We have webinars planned out through December 2020, and many are open for registration. All attendees are in listen-only mode. Please type your questions in the chat box and they will be answered in the order they are received. If we run out of time, we still have questions, responses will be sent directly to the person asked the question by our presenter. Professional continuing education credits and AIA CLUs are being offered. For AIA certificates, please send an email to Billy, B-I-L-L-I-E, @apa.org with your membership number. If you did not indicate you wanted their certificate at registration, just send me an email. If you shared your call information, make sure you send me an email as well so everyone attending this session gets credit. At this time, it's my pleasure to turn this over to Carolyn Farley, Education Specialist at ZERT. Carolyn, take it away.
Thank you so much, Billy. I appreciate the chance to speak with you all this afternoon. And just by way of a little bit of my background, I worked for 25 years on university campuses and served in the role of project owner for the Division of Student Affairs, the Provost's office, and so have worked on classroom buildings, student centers, residence halls, and so through that became familiar with manufactured interior construction and have since started working for one of the manufacturers thereof. So we'll talk through this today, kind of giving you a sense, and I will flip now to the objectives for today's program, and we'll leave plenty of time at the end for your questions. I will apologize in advance if you hear some barking in the background. My dog has taken it upon himself to be the social distancing police in my neighborhood. So occasionally he has to remind people how to behave. So hopefully we'll get through this quietly. So our objectives for today are to understand the advantages of manufactured interior construction in terms of faster project delivery, cost savings, quality control, and health, safety, and welfare. We will analyze how this construction type mitigates risk on behalf of both the owner and the contractor. We'll list the benefits of manufactured construction in terms of life safety, health-related concerns, safer construction sites, and healthier interiors. And then also explore the design features of manufactured assemblies from the perspective of individualization, agility, and ability to evolve with educators' needs. Now, you and I can both be relieved that I am done reading for the day and stepping into some good content. So, wanted to give you some context for this approach to construction. It comes into a warm shell provided by a general contractor. So at this point in time, there's not a fire-rated assembly associated with the manufactured interior. So the general contractor is taking care of that. But my reason for stepping through this is that there are several handshakes with other sub-trades in this sequence that look a little bit different than they would with traditional construction. And in this example, we're starting with the ceiling. So the ceiling contractor is coming in and working in an open plane. So you can imagine that while he or she might use roughly the same volume of material with this approach, they're going to move through this effort much more quickly, so your labor costs will go down. So these are the types of handshakes and all that we need to understand, both for those who are doing any estimating, and also the subs need to understand, both to the benefit of their own schedule, but also to the benefit of the client, who should be recognizing a less expensive install effort because they're not having to move in and out of spaces and cut tiles. You also see that the light fixtures here have already been suspended. In this example, I'm going to show a raised floor. It's not a requirement of this approach to construction, but it is an option. This particular floor is less than 3 inches high. It is intended only for the distribution of power and data. It's not intended for the distribution of heating and air conditioning, so you don't need to use plenum rated cable. The puck provides the structural support for magnesium oxide tile, and the webbing provides the pathway for the cabling. So again, thinking from an installation perspective, this would go very quickly because somebody's literally dropping the wiring into the webbing pathway. Again, putting those tiles back in, and your flooring contractor too is working in an open plane, because the manufactured assemblies rest on a finished floor and clip to a finished ceiling, whether that be a soffit or a drop ceiling. So that, again, they might use roughly the same volume of material, but they would be able to be on and off this job site more quickly. And in most of the markets where I spend my time, I cover pretty much everything east of the Mississippi in the US. Our skilled tradespeople, those pools are shrinking. And so a labor pool being able to move on to the next job is always something that our subs are finding attractive. So this is a good option for them to consider. We're going to show this wall being clad with a manufactured assembly. Wherever you see a horizontal is our version of blocking. So it's that structural support if you want to hang furniture or anything else from the wall assembly. So those will show up as reveals and can provide that structural strength that may be needed for what you're asking the wall to do for you over time. So we're going to bring some demising walls out from that. We're going to bring power to the outlet that you are seeing there. We're going to pull it in from the floor. And that manufactured, the outlet, the wiring, the conduit, and the cabling are all part of the manufacturing process where that is permitted. Certainly it looks a little bit different in a unionized environment where they want to be pulling the wiring themselves. But I live in the South, and we use what we call a level 4 solution of power, which allows us to bring everything in a plug and play solution. So again, your electrician is needed to set the base building panel and to connect it to a zone or a junction box, but everything else is done with a manufacturer provided plug and play solution that can be handled by the certified installers. So it's at this point in the conversation that your inspectors would be coming in. They will find that everything is UL stamped. And then applying the assemblies, we're going to finish the space out using some glass fronts and up to and including the doors and the campus preference for a lock solution, and then also being able to kind of lay in the furniture of their choosing so that they can have a really robust experience in this space. So this gives you a nice sense of kind of what all is coming in and provided in that pre-approval phase. So able to look at a space in 3D. We can even do a virtual reality experience so that the end users are fully satisfied with what they have a chance to bring to their site. So this is a point where I often kind of ask questions and wait for people to answer, but I'm not going to do that today because I can't see your faces, and it's creating a fun dynamic for me. But there are two important drivers for education, and those are pedagogy and the health, safety, and welfare of building occupants. So we're going to talk a little bit about teaching methods, and what we're looking at here is a technology-enabled active learning classroom, or a TEAL classroom. As you can see, we're starting to lose the front of the room. We're moving away from a stage on the stage approach to instruction to one that is far more interactive and allows for those who are engaged in the learning to be participating in activities that will enhance the content that is being conveyed. So working in small groups, you'll often notice that all of the furniture is on casters. I just suggest that wherever the furniture might move, that there be an outlet for people to plug into and some technology for them to share. Next, we'll look at a flipped classroom, and this is really more so about kind of when the content is delivered. You know, back in the day, I won't tell you how long ago, I would go to a class and a faculty member would lecture to me, and I would go home and I would do the homework, often kind of a solo activity. But now what we're doing is encouraging students to take in the lecture content as their homework and come to class prepared to be engaged. And this allows a faculty member to circulate through the space, to engage the small groups in conversation, and to really begin to grasp whether or not individual students have a handle on the content without necessarily even having had to give a test at this point. So it just allows for those who learn in different ways to kind of be engaged in the ways that serve them best. And that really speaks to the universal design for learning. What we're trying to do is make sure that content is delivered in ways that meet a student where their skill set is or where their preferences are. So very early in a young K-12 experience, we're taking some time to find out if they are auditory learners, if they're visual learners, kind of where their preference is for taking in information, and making sure that the content we have can be delivered in a variety of ways so that students can be embracing it from a perspective of their choosing and a place of strength. And then personalized learning environments. This is something that has really come to the fore in the last few decades as we look at those learning styles and really helping students to move along. And some of the benefits to this that we see are a level of increased student engagement. And this is all based on research that's been done in these environments. We're seeing greater student retention, higher grades, improved test scores, better attendance, and oh my goodness, the performance of the staff also improves. And I think it has a lot to do with interaction, which, we are doing that in a modified way today, much as our students across the country are engaging with their faculty and their instructors in different ways. But it's still a way for us to be connecting with one another and sharing information. Maker spaces have become a big part of the conversation. And, the days of our libraries with their enormous volumes of books have started to fade in memory. Those books are either being digitized or they're being placed in compact storage to make way for learning centers and maker spaces. And so these 4 students could be working on the same assignment, but they're choosing different tools and finding ways of learning from one another because they're working in a common space and they're seeing how one another's making or meeting those challenges. It just is a little bit different perhaps from the way of their choosing, but all of them have an opportunity to engage hands-on in kind of meeting the challenges of the assignment. So what will tomorrow bring? I mean, this doesn't necessarily look like a classroom of tomorrow. I think it's something that we can all relate to, is something that we would expect to find on many campuses today. But, if we start to press ourselves a little bit and ask questions about what this learning environment's going to look like 5, 10, 15 years from now, I think we can agree the technology is going to look different. The arrangement of the furniture may look very different. We may have a blend of both remote and, present learners in the same class. So we need to be looking at these spaces in a way that allows them to remain very nimble. And what we've learned from building with concrete block is that people will live with the pain of the concrete block rather than live with the pain of what it means to change that. And so with the manufactured approach to construction, what we're saying is let yourself off the hook a bit for having to predict what the world's going to look like 5, 10, 15 years from now, and embrace a method of construction that will allow it to continue to evolve in smaller increments over time to meet that new technology, to meet those new teaching environments in some really meaningful ways. So we'll talk a little bit about the issues of health, safety, and well-being. Certainly safety and security tools are something that we are all spending a lot of time talking about these days in most environments. And so we have mag locks, we have embedded cameras to provide surveillance of areas, we have card readers to allow access, and then also include, a tablet or something that can let you know what's going on inside a space. And these tools are continuing to evolve. And, the nice thing about this approach to construction is that wherever you see one of those reveals on a tile behind that card reader in particular, or under that camera, that's a place where a tile can be removed. So even if the choice of security tool comes along later, there is an opportunity to install it in an active environment, because the noisy part is maybe routing the hole in the tile for the camera or attaching these tools to it. And that can be done very quickly, very quietly in a remote location, with the tile then brought back to the space with the appropriate power brought to it. So these tools don't need to wait to be installed for a significant break period. They can be installed in an active environment or in just a few hours over the course of a week. Balancing transparency with safety. I think, we all think a lot about what it means to be in what we consider to be a safe environment. And for some, the level of transparency afforded by a lot of windows in a space can feel a little counterintuitive at times. Aren't I more vulnerable if people can see into the space? But what we know for the sake of learning is that all of us thrive in natural light. And so we don't want to diminish the opportunity to be bringing the natural light into a space. So we have to look at, how do we provide that transparency and consider issues of safety. If you all haven't taken a look at the new Sandy Hook School, that's a project that I look to very often and I refer people to when I'm talking about this. They did such a lovely job with the topography of the space and managing the access points to the environment that I find that to be, it says more in a few pictures than I can ever say relative to this in a short conversation. So if you have a few minutes and can take a look at the beauty of that school as it now is, they did a really lovely job in a really difficult set of circumstances. So looking at some of the tools that we're seeing in this picture on the left, you see there is a robot that is attending school on behalf of a student who may be at home for an extended period of time due to an illness or maybe recovering from an injury of some kind. And so this robot is literally, moving through the school spaces with other students and taking in the content and delivering it to that student at home. In others, we see these active learning environments where we have students that are getting connected to the technology that's available to them through connections made on the wall so that they can be sharing their content with others in the classroom. And then also looking at the integrated technology when it comes to issues of wayfinding, campus-wide announcements, those types of things. And all of this is something that we're seeing and finding much more common on campuses. But then we're also looking at issues associated with respiratory issues, whether it be asthma or others, ADHD, so trying to manage attention deficit issues for our students, looking at ways of kind of bringing fresh air into a space, and considering, some of the challenges that we can have in these environments. And we'll talk through some of the ways that these can be mitigated with this approach to construction. So some of you may think of manufactured interior construction as more of a pod. So this picture that we have here, I always picture that it's a bathroom pod because I was responsible for building a residence hall and looked at manufactured bathroom pods for a minute. Think about the lead time on this, how far in advance you need to do your planning to resolve the design so that it can be manufactured off-site, freighted to site, craned into the building while it's still open. So you're making your commitment to this design well in advance of needing those materials on site. Whereas when the material comes to site as an assembly, you have a lot more time to get into the project, particularly if it's a renovation and you haven't gotten into demolition where you might find yourself with some unforeseen conditions. These assemblies can be to site within about 4 weeks. So think about what that allows for your design time. You're really uncovering everything, designing to your solution before you have to hit send on the order entry. And then 3 weeks to 4 weeks later, these assemblies are showing up on site, ready to be installed, complete with things like what we're seeing here actually is a healthcare head wall. It's much more complex, but it gives you a nice picture of what the capabilities are, because we're seeing medical gas lines, standard and emergency power connections, and all of that work that you are seeing here has been done in the factory. Yes, there is a handshake to be completed once the assembly is on site, but think about the number of trades that aren't touching this or aren't touching it, at least for the duration that they would have under other circumstances had we been doing this conventionally. So this is a nice snapshot of kind of some of the efficiencies and our opportunity to mitigate risk for project owners and general contractors as well. So this project was done in Detroit. It was about 36,500 square feet of space. And you can see the trades marching in the order that we're accustomed to seeing them. We have our inspections, a punch list, and a project closeout at about 17 weeks. They actually completed the project using the manufactured approach to construction. And that's what you'll see on the next slide. And you start to see the labor pools getting smaller. So yes, you still need all of these trades present, but for example, your painters don't need to touch the manufactured solutions that are brought to site because they arrive finished. So when those come to site, they are installed by a smaller labor crew than would have been necessary to build out conventionally. And you've just saved about 3 weeks of time. So even if the cost of these two things are relatively comparable, the asset that the institution owns at the end of the day is more valuable because you haven't paid for time, as much time. Typical time savings is around 25% of a conventional construction schedule if you're using the full capabilities of a manufactured construction solution. The adaptability possibilities are really wonderful. We were talking about that when we were looking at that classroom space. Just envision that originally here, that was just a solid wall panel, but now they've decided to install and embed a television monitor. The manufacturer provides everything, including the bracketry, a power chassis for all of the connections that need to be made, a fan kit that can be installed to keep that monitor cool. It does not have to be a commercial grade monitor, nor do we much care who manufactured it. We will advise the client as to how deep the monitor can be to fit in the wall cavity that's created with this approach to construction. And then on the right-hand picture, you see them placing a piece of back painted glass over that monitor to protect the larger portion of your investment that is made possible there. And that type of change out, removing the former panels, feeding in the bracketry, the wiring, putting the new monitor and the new glass in place, that exercise is probably at most about a 90-minute exercise. So know that over time, you might build out a room without a monitor embedded in it initially and be rolling something in, but in time, when the budget allows, these layers of functionality can be added. So this also touches a bit on that value proposition I alluded to when we were looking at that risk mitigation slide. So in conventional construction, about 70% of the cost of your construction is in labor. In a manufactured approach to construction, that's flipped. About 70% of your cost is in materials. And that's the asset that the institution ultimately owns. So thinking back on, I did a student center project at my last job. We had a $38 million construction budget. I used manufactured construction on a small footprint. It was about 2,500 square feet for a campus visit center. When I think about 70% of $38 million walking off the project and thinking about what it would mean for the institution, if I had had the opportunity to use it more broadly, it was a kind of our first step into this approach to construction. Knowing, I had a new vice president join the staff while we were under construction. He had a different vision for the some parts of the building. Of course, it was for those portions of the building that had not been built out using this approach to construction, because that would have made those much easier to change and adapt to that new vision. As it was, would need to find not just the money to do it, which is a big factor, but it's also the time and opportunity in a building that is very busy 12 months out of the year. And I realize how tone deaf some of my comments sound in the current environment that we're in. So I hope you'll forgive me. It's I think we're just all doing what we can do here. So looking at some new behaviors, and what you're seeing here on the left is literally a construction site using the manufactured approach. It's a recycled denim insulation. It's aluminum framing that's about 50% recycled content. And it's a very clean construction site. And so think about the fact that we're bringing in assemblies that rest on a finished floor and clip to a finished ceiling. It's also not making a lot of noise. So if you need to work in an environment where there are adjacent offices that need to remain active, this is a much less disruptive way of accomplishing that. And so in the middle picture, we're seeing, the use of the raised flooring to distribute both power and data, and seeing the use of the embedded technology here on the right-hand side. So again, looking a little bit, and this is a healthcare model, but they do a better job in general of kind of measuring the cost of operations given their financial model. And so they developed this and show us that, operations and maintenance of a facility at about 58%, 29% of that in refurbishment, where we would also see any changes, changes in sizes of space or functions of space, those types of things. So looking at that 29% number and thinking about how much that number could be modified, reduced, if we knew that those changes could be made because the manufactured approach to construction makes them so much less disruptive. There was a campus where we actually moved a student health center from the 3rd floor to the 1st floor of a building. And they weren't fully operational the day that we were complete, because some final measurements needed to be done for a few pieces of glass to be installed. But that literally was about a 5-day effort, and it was about a 2,200 square foot space. So when you think about what that would have cost, both in time and disruption, conventionally, you start to really see some of the advantages here. And integrated design is really the story here. Ideally, the manufacturer would be involved in the conversation very early on. Programming really isn't too early. Schematic design is ideal because there's an opportunity to, it's kind of like deciding on your heating and air conditioning system. You're thinking about that very early in the project, and it starts to drive some other decision making. The same thing can be said about this approach to construction. I can make a commitment that the manufacturer knows where this is a good fit and where it isn't a good fit, and that will be very clear going into the conversations. But helping others to see where the handshakes are, where there are opportunities for developing some efficiencies, for a cost savings to be returned to the owner, all of those things happen early on. Once you start estimating a project, the opportunity to clearly see and price those efficiencies can be more difficult. So looking at teaching methods and health, safety, and welfare of our student-centered design, I'm going to show a quick video here. So let me bring this up.
Challenges we faced were having the flexibility to meet the students' needs. And the mountable wall system seemed to be the solution to that problem, but then choosing the right mountable wall system to meet our needs, to have the flexibility and to look good.
The durability, the acoustics were also very important to this group. The removable skins of the wall really allowed for future damage
those to be mitigated?
Carolyn, just wanted to let you know that the video is skipping.
It's skipping. I will make sure that I send it out with the content so that people have it. I apologize for that. I know that videos always tend to kind of be the challenge with these. Would you like for me to allow it to run, or do you want me to stop?
I would say stop. That way we can, because you have a lot of questions.
Okay, fair enough. That's all.
Thank
That's all
you.
fine. Sure thing. I apologize for that. We tested it on the front end, but I know it can be a bit of a challenge. So, okay. Know that that's a really great story and that we will get it to you for sure. Response to integrated technology. We talked a little bit about this up front, but one of the things I appreciate so much from, the days that I worked on a campus and was responsible for managing budgets for various student facilities is the ability to protect your major investment, your monitor, and that it doesn't need to be a commercial grade monitor. The monitors that you're seeing in the picture on the right-hand side, we have changed their context over the years, but they are now 11 years old and they are functioning at a very high level. What we have done over time is layered on some technology. So we have applied a film, it's called Displax, to the backside of the back painted glass, which allows that to become an interface for teachers and their instructors to be using. You can barely see at the top of the right-hand screen there an e-beam that allows you to create a conference environment for that space. So the integration of the technology, the inclusion of a volume of writable surfaces, and there are a variety of things available. But then in the left, you see you can secure the smaller things or the more expensive investments like your CPU and things like that in a cabinet that can be locked while the students and everyone can still have good access to it. In this, we're showing the manufactured approach to the ceiling or floor distribution of power and data. This is the flooring we looked at a little bit earlier. Ceiling distribution is also permissible. Everything down to the zone and junction boxes are manufactured off-site. And as I said, it comes as a plug-and-play solution to the environment so that the certified installers can be making those final connections. So you don't need your electrician to stick around to this point in the conversation. Another thing we have found is that inspectors, once they recognize that it's a manufactured assembly, a manufactured connection, and they're not having to look for the difference between a master electrician and an apprentice's work, the inspections can go more quickly, which I think all of us can appreciate. A passive optical network, this has not taken hold in a significant way in higher education quite yet, but it's very popular in the hotel industry, and it will make sense to you when you hear a little bit about some of the major differences. So what you see on the left is our conventional copper run, a bundle of 96 cables that we have trays and switching equipment for, and for which we have to set up multiple closets in many facilities because the run of the cable themselves has kind of a point of diminishing return, and so the signal starts to trail off. Having been responsible for residence halls, there is no upside to having your signal diminish. Students will let you know in a nanosecond that has been happening. What you're seeing on the right-hand side is passive optical network. So instead of bringing the fiber to the edge of the building and transitioning to the copper, the fiber is coming further into the building. The fiber's been tested up to 12 miles and has not shown any diminishment in its signal. You do still need to convert to copper. Copper is still king when it comes to making the connections to our devices, but it happens at this device that you're seeing, and it happens fairly close. It can be in the wall, it can be in the ceiling, but happens pretty close to the end user and their equipment, so that we're talking about yards of copper instead of miles of copper on our projects. And copper ages out. So the fiber is just giving us a lot more life and a lot more strength. And that has been a pretty exciting transition of things. Whereas you might need a 100 square foot technology closet every couple of 100 feet in a large building with a large floor plate. With the fiber, you need a single closet of about 20 square feet to serve most typical buildings. Now, this starts under 25,000 square feet. This will be at a premium, but over 25,000 square feet, you will start to see the cost go down both on the construction side, because you're not building closets for copper anymore. You're able to deploy that square footage in some other ways. But then you also have operational cost savings, because you're not looking at some of the aging out of the copper and some of the cooling factors that come into play in that particular world. I will admit at this point that I am an English major, a very proud one, and I feel good about what I've shared with you around the passive optical network. I am happy to put you in touch with other people who can take you further into that conversation if you would choose. So looking at issues of indoor air quality, this is a manufactured living wall. It has its own wicking system to allow for each of the individual plant pots to be watered as a part of that system. But think about this as a teaching tool in a classroom, both from the student's ability to grow plants, but also potentially understand, what they can derive from a garden and the fresh air that it brings into a space that might not otherwise feel as fresh as you would hope. I know that there's still a few campuses out there that are managing issues of asbestos in their spaces. This was actually a project that we did on a campus, and they made the choice. I know it is not of everybody's choosing, but they made the choice to do a targeted abatement of asbestos wrapping on the pipes that they had in their existing space. And they were able to do that because the design software that we use is so precise that we could identify where the contact would be made. So the targeted abatement proceeded, the walls, the manufactured walls were put into place and serve as encapsulation for the balance of the material that remains in those walls. I love this picture on the right because you can see that they kept the old door openings and frames in these spaces while kind of bringing a lot of technology and writable surfaces to what is an older classroom environment. And this is a project type that we're doing more and more of. There are no VOCs in any of the paints or adhesives that are used in this approach to construction. So if you're working in an active environment or adjacent to an active environment, you don't have to worry about the potential of creating respiratory issues for those that may be in an adjacent area. And then looking at the acoustical performance of these spaces, it's a little bit ironic that we're showing a glass wall in that, because we don't have magic glass. Our glass is like everybody else's glass. And so if that's a finish of your choosing, there are a lot of conversations that we have to have around managing the sound transmission there. But these assemblies have been tested in a laboratory and have shown performance. The substrate is MDF, which performs at a higher level of managing sound transmission between spaces than conventional drywall construction does. So when we're looking at a sensitive space, like if you have a student health center and you want those spaces to be at a higher STC level, we would look at some options available. We can add layers of insulation. There can be mass-loaded vinyl within the wall. There can be details that are added to manage sound transmission between spaces more effectively, but know that this performs as effectively as a drywall and beyond what a drywall assembly is capable of doing. Sustainability is a big story on many of our campuses. And depending on what the institution is pursuing, the design software that we use is capable of generating a report that can track everything from the carbon footprint of the freighting of the materials to the volume of drywall that's been kept out of a landfill, to the volume of recycled content in the materials that are used, so that if an institution is pursuing certification, they will have a document that gives them that information. And certainly there are institutions too that just want the bragging rights. They're not prepared to pay a certification fee, but they value this as part of their institutional mission and want to be able to demonstrate that level of responsibility for the choices that they've made. So some of those things that we can demonstrate as part of that certification: the volume of reusable and recyclable material, the fact that the walls can be moved, that they can be taken from the space that they are currently in and moved to another space, or they can simply be asked to behave in a different way, like embedding a television monitor in them. And then the access floor and ceiling really giving you that ultimate flexibility for the reconfiguration of a space and the ability to add electrical and change the routing if you need to. So we are here at our wrap up, and I will jump into some questions, but wanted to, did I get the right, I need to check and make sure I grabbed your right slide. I think there's another slide that you gave to me, Billy, that I need to post, but I can be doing that while I'm taking some questions.
Okay, is the raised floor system waterproof? Most schools use a floor washing ride about the size of a lawnmower.
You know, I'm familiar with the equipment, and if you're using, in most circumstances, you're using a carpet tile on this, and it's not the type of machine that would saturate the tile. So I think I would feel fairly safe to confirm that, but let me make sure of that before I answer that. So I will make a note of that and make sure that I get back to you with that. So Billy, if I can get the name of the person that asked that, I will do it, or post it to the group. I'm fine doing that too.
I certainly will. How bouncy is the raised floor? Does it feel empty?
It does not. It's really very solid, because I have certainly experienced some spaces with a really tall, like 16 or 18-inch floor where you are distributing heating and air conditioning that both rings and feels bouncy. It has a magnesium oxide tile, so it doesn't have a bounce to it. And it's one of the reasons that I really appreciate it. And from a weight perspective, actually one of the applications that I have recommended is the consideration in recreation centers where they're putting their fitness equipment. So you think about the weight and the footprint of those, but if we're building that space conventionally and you decide you want to move your equipment around, you're really locked in by where you have put the outlets from the beginning. But if you use this raised floor in those types of environment, it can take the weight of the fitness equipment. You would really have a lot more flexibility.
Okay, thank you. At the beginning of your presentation, are the floor spaces closed on top?
The floor spaces closed on top.
Are the office spaces closed on top?
Oh,
at the beginning of your presentation,
good
are those
eye.
office space closed on top?
Good eye. I give whoever asked that question gets like bonus points, because not everybody recognizes that. This one is not. This one falls short of the ceiling, and this is something that is possible, part of our capabilities, and this is possible in this configuration. We're able to manage it because we are connected to the wall, as you can see there. We can come out from that wall and it's providing the structural strength. Certainly if it were a standalone environment and the runs were beyond what we could handle through like literal geometry and physics, a steel post may be required. But in this type of configuration, we're anchored to the wall and resting on the finished floor, not clipped to a finished ceiling. This type of configuration has growing interest in spaces where you don't want to go to the expense of moving your heating and air conditioning supplies and returns or interfering with your sprinkler system. So this capacity to fall a bit short. In most jurisdictions, I'm finding it's about 18 inches. The other option is that the frames can go to the ceiling and we can leave an open clerestory at the top. So it looks like it finished to the ceiling, but it actually falls a bit short. So good eye. I send you a gold star virtually for recognizing that.
Thank you. How is sound transmission between spaces controlled?
I mentioned with glass, we don't have a magic bullet for issues with glass, but the solid surfaces that you're seeing kind of in that pale wood-like color in there, the solid tiles typically outperform what you would find with a standard drywall construction. So low 40s with just the standard construction and a single layer of insulation. If there is a particular goal for a space, we will work with the campus, the architect, and if necessary, an acoustician. If you're really zeroed in on something like a 50 or 55, we can control for the 4 surfaces that we are bringing into the space, but the ceiling plenum, we need to be taking that into account. The ceiling tile would need to be meeting that same standard. So we really try to look at it holistically. You know, let's not line up our outlets back to back and do some of those things that can confound the best intentions. So we really, it's not unlike conventional construction. That's one of my colleagues likes to say, in either case, you're stuffing dollar bills into a wall because you're raising its capability to manage that sound transmission between spaces.
Okay, thank you. A question for you. Can a source be added to the slide for where you found the statistics for personalized learning?
I will find that note because I know it exists in the notes that we have for the presenters. So yes, we'll pull that out.
Thank you. What are the acoustic values versus a standard stud wall assembly?
Just making myself a note. I'm trying to figure out how to answer this differently than I answered the one about the STC. There are some options that allow for, like, we have some tackable surfaces, there are some micro perforated surfaces that can allow us to do more with an NRC rating of a space. So to make it more capable of absorbing some noise, that helps for those who are within the space. It will not necessarily help with the sound transmission to the next space. So those are all things, looking at the project holistically and helping us understand the goals very early on, we can bring a variety of solutions. So the extra layers of insulation can be added. I worked on a project recently where a layer of mass-loaded vinyl was placed within the wall cavity to manage, to raise the STC value of that particular wall. So I certainly have some information additional information I can share if there is interest.
Okay, thank you. What difference do you see in CapEx needs and overall costs between conventional versus manufactured? Will they last the traditional 30 years of financing?
This particular company, I work for Dirt Environmental Solutions. It stands for Doing It Right This Time. This company has been in business for 16 years at this point. So, you know, no, we haven't lasted, nobody's tested us to the 30 years, but there's no reason to believe that it won't bring that value. And I like to point out that, yes, we are continuing to innovate. We've just added a 2-inch base to our list of options. Our standard had always been a 4-inch base, but everything we manufacture continues to speak to each other. The name of the company is Dirt Environmental Solutions. Sustainability is very much a part of our DNA. So that 2-inch wall assembly can turn a corner and connect with our 4-inch wall assembly. So we don't design to obsolescence. So it's kind of like a box of Legos. So maybe your parents had Legos and your children have Legos. You know that you can throw them all in a box and they all play together. And that's really DIRT's approach to design, is that if somebody bought something 13 years ago and they need to make changes to it, what we manufacture today will still meet their needs.
Thank you. How is fire sprinkler and fire alarm installation handled with these types of projects?
Fire sprinkler, all of that work would be done in advance of the assemblies coming to site. And since these drawings, you know, what we do is take the drawings created from your vision on the campus side through your architect to those files. So a CAD file is sent to us and we apply, lay on our assemblies in line with the vision of your finishes and the architectural vision of the space. It sounds a little counterintuitive, but we have no standards. Like there aren't a bunch of 4x8 assemblies in a warehouse that we've been told to offload. Every project is manufactured to the specifications of that environment. So that 3 to 4 week lead time that I talked about, we go in and do site dimensions in a warm shell. So, you know, the design of where your sprinkler heads would be part of the same set of drawings that these assemblies would be. So we're making sure that there aren't going to be interferences with, you know, the top edge, in this case of a cornice height or a short of the ceiling height wall, and where a sprinkler head needs to be. So all of that coordination is done in the architectural files. So, but we can mount strobes, we can put, you know, cases for fire extinguishers in these walls. Those, you know, fire safety things that need to be incorporated into the construction can be incorporated into these walls.
Okay, thank you. Next question. Do these systems have applications for residence hall bathrooms?
You know, we've spent some time, I've spent a lot of time thinking about residence halls, having had that responsibility. I think we don't typically do a wet wall. So it would depend on kind of what you were trying to do in the residence hall restroom. Like if you're talking about stall separation, that certainly would be an option, but I wouldn't use it necessarily like to divide shower spaces. We can apply tile to it, so it could be the wall behind, like, you know, where you line up some sinks. But with the MDF substrate, I am mindful that of the contact with water and needing to manage for that.
Thank you. What about maintenance of electrical? As the space is used over time, can any technician work on it?
Great question. And really on the campuses where we are currently doing work, as we're wrapping up a project, we will talk to the facilities team about the level at which they would like to have their in-house staff trained. So if you would like for the staff to be able to, and it requires a tool to take a tile off a wall, but we would leave you with a set of tools. So if you want to take a leak through a wall, you can remove and replace the tile. If you want to add electrical, we will show you how that can be accomplished, and we can have, you know, a manufactured assembly for that outlet sent to you from the factory. It's really, in most cases, going to be less expensive than what you might work with if you had like a local contractor doing that work. So we are happy for you all to be able to manage up to a level of your choosing. I mentioned several times that we use certified installers, and we reference that because this comes with a 10-year warranty. So we certify installers. So yes, you could have staff on your campus trained up to the level of being able to move the walls or to embed technology, but they would need to go through a training process with us, because that's how we manage that warranty, is knowing that the projects that are on a more complex scale are being handled by folks that we know have been trained appropriately. And the training goes with the individual. So, you know, we've talked to a couple campuses, and they're looking at, you know, maybe somebody in their carpentry shop being a part of that type of training to actually be able to move a wall.
Okay, thank you. We have time for a couple more here. Can your system also be used as a half wall to create a workstation model?
Yes, it can. And something that I would like for you all to understand, this can be purchased out of either your construction budget, so under the general contractor materials, or it can be FF&E, which I'm running into some projects now, and I ran into this myself on my own projects, where the capital budget is tight and you need to offload some of the interior construction you need to offload something in order to finish out the project in a way of your choosing. Maybe you end up shelling a space, and I always found the FF&E budget a little bit easier to replenish over time than purchasing these types of materials from the FF&E budget may allow you to finish a space in a way that you would not have had you pursued it conventionally.
Thank you. Design changes during construction will affect air handling and fire sprinkler placement, as well as lighting. How easy are these to change? How easy are these changes?
They are relatively easy, and given the short lead time, the heating and air conditioning, that distribution should be accomplished by the time we would be doing site dimensions. So we would be in a position to recognize if something had moved and we hadn't been advised of that yet. Our goal is to be a super sub under the general contractors. So to be a part of those coordination meetings where those kinds of conversations take place, so that we can keep up with the impact that any of those changes may have on the design. The nice thing about what this does, given, you know, how robust the experience is and taking a look at it and how far into your project you can be, the chances of there needing to be a change order once this order has been sent are reduced significantly. So when you think about how much a project might spend in change orders, that's, for me, was a real comfort.
Okay, thank you. Would you say it is best to have no drop ceilings in the classrooms?
No drop ceilings in the classrooms. You know, they do provide for that acoustic management. I think so much of it has to do with how the balance of the space is finished. You certainly want the instructor to be able to be heard, so you need a certain amount of flexibility and sound transmission, enough to carry. You don't want every surface to be dampened. So I think it needs to be looked at holistically. You know, what's the flooring, what's the wall composition, how much glass, you know, windows do you have in the space, and to really consider how that might impact whether there's a need for a drop ceiling, or you could go with an open plenum space.
Okay, well, that concludes the most of our questions. The other ones I will send to, and we have a couple more at the very bottom here. Do you have fire rated walls?
Not currently. I say that because we are in testing, but when somebody asked about residence halls, I appreciate that the demising walls between bed spaces or between apartments units need to be fire rated. But that is something that we are in testing and would anticipate having in the future.
Okay. Well, we're almost at the top of the hour. I want all of those who are still on the line to know that I will be sending you a copy of the presentation slides out either later this evening or sometime tomorrow or over the weekend, but you will get them, along with certificates will be coming as well. And if you have an AIA membership and you would like an AIA, me to report that you attended this for AIA credit, just send an email to me at billie, B-I-L-L-I-E, @appa.org. Thank you so much. Carolyn, it's been a pleasure. It's been very informative. I thank you for taking time out of your schedule to do this, and I want to say thank you to our attendees as well.
Absolutely. I enjoyed the chance to do this, and everybody stay well. Thank you.
Thank you. Have a great afternoon, and we'll see, hopefully, most of you tomorrow on our town hall. Thank you. Have a great afternoon. Bye-bye now.
Bye-bye.